Okay, is it recording? Yes, it is. Here's your formula. This formula is called Ohm's law. Its voltage is equal to resistance times current. Remember, the formula is made up of variables, so V, I, and R are variables. So V is voltage, and the unit is a V. I represents current, and the unit is an A. And I put too many marks there. R, that variable is for resistance. And the unit is the sign omega. And we say that as ohms. That's what the omega stands for. Resistance is measured in ohms. Okay, example A. What is the resistance of the heating element in a car-locked de-icer that contains a 1.5 volt battery supplying a current of 0.5 amps to the circuit? All right, so here's our formula. Voltage equals current times resistance. We are looking for what? Resistance. So we have to solve for resistance. What are we going to do? Divide out I. Whatever we do to one side of the formula, we have to do to the other side, so we're going to divide out I over here, cancel out I, and we see that resistance is given by voltage divided by, correct. Now we can plug in the numbers, so we've got 1.5 volts divided by 0.5 amps, and that gives us 3. And the unit is the ohm. Okay, example B. Justine's hairdryer has a resistance of 9 ohms when first turned on. How much current does the hairdryer draw from the 110 volt line in Justine's house? Okay, so our formula is voltage equals current times resistance, and this time we're looking for what? Current. So what do? Solve for I. We have to get rid of R, divide it out. Whatever we do to one side, we have to do to the other. Cancel out I, or cancel out R, and we see that current is given by voltage divided by resistance. Okay, so the voltage is 110 volts divided by the resistance, which is 9 ohms. 110 divided by 9 is? Okay, we can round that to 12.2. What's our unit? A. Okay, that's easy enough. Example C. Find the total resistance of 3 resistors connected in series. So this is a circuit, and we have 3 resistors connected within the circuit, so they're connected one right after the other. That's called an in-series circuit. This symbol, this squiggly line, that's the symbol for a resistor. This tells us that the amount of resistance it's giving in this circuit is 12 ohms. This one gives us 4 ohms. This one gives us 6 ohms. Okay, to find the total resistance, R total is going to be equal to the resistance of number 1 plus the resistance of number 2 plus the resistance of the third resistor. So this is very simple. Yep, 12 ohms plus 4 ohms plus 6 ohms is 22 ohms. So that's the total in series. For example D, we want to find the total again, but this time they're not connected in series, they're connected in parallel. Well, you'll see. Hold on. So when it's in parallel, we've got the wire coming in, the wire splits 3 ways, it continues, and there's a resistor on each route of the wire. After the resistor, the wire comes back together to one wire. So this is a parallel circuit. So here's how we find it. 1 over the resistance total is equal to 1 over resistance 1 plus 1 over resistor number 2 plus 1 over resistor number 3. When we're adding fractions, what do we have to do? Common denominator, that's right. All right, so I'm going to set them up without the common denominator, then we'll find the common denominator. So you guys can, if you're looking at this later, you can figure out what we did. So it's going to be 1 over 12 plus 1 over 4 ohms plus 1 over 6 ohms. Common denominator is going to be what? 12. All right, so that's going to turn out as 1 over 12, 3 over 12 plus 2 over 12. Add them together and we get 6 over 12, which reduces to 1/2. So let's see if you can get this. What is the total resistance? Think about it. 2. Very good. All right, so remember the total resistance was in the denominator here. So it's going to be the 2. Yeah. 2 what? Okay, good. All right, this is the toughest one. This is not very difficult unless you missed the teaching of it. Then if you tried to look at it, you'd be very confused. But it's really not too difficult. In this case, the total resistance, so what we've got here is we've got a circuit. Here's our voltage source. We have a 16-volt battery. Here's our circuit. Here's our wire. It first hits a resistor, so this resistor is in series. Then the wire splits, and we have 2 resistors in parallel. And then, of course, we have to go back to the source because it's a circuit. So the total resistance is going to be the resistance in series plus the resistance in parallel. The resistance in series is equal to 4 ohms. There's only one of them. It is. 1 over the resistance in parallel is equal to 1 over 12 plus 1 over 6. Common denominator is 12 again. So that's 1 over 12 plus 2 over 12, which is 3 over 12, which reduces to 1 over 4. The resistance in parallel is 4. So the total resistance is equal to 4 ohms plus 4 ohms is equal to 8 ohms. But that's not what we were looking for. In this problem, we don't want the total resistance, we want the total current. Our formula says that voltage equals current times resistance. Divide out resistance, divide out resistance. Current is given by voltage divided by resistance. Yes. 16 volts divided by 8 ohms is equal to 2 amperes. Good. All right. This one is due on, I believe it's Tuesday. Check your calendar and see if I'm right. Yeah.